All right, it is 8:01. We are back in business again. So thank you everyone for your patience this evening with me. And welcome to Sailing and Boating Basics weather webinars with WRI. And I am Captain Deb Marler, and I am coming to you from outside of Panama City in down in uh, down by the Panama Canal. So um, we are enjoying some beautiful, beautiful weather down here in the mid 80s. And our boat Simplicity is over in Colombia, and that's a story for another day. And so let me just move that. I do want to invite you as we go into this. For some of you who were not here for the earlier session, thank you for joining us. For those of you who are with us, um, do write down your questions. You can put them in chat. We will have a Q&A session as well with this session as well. And, you know, we have our more advanced curriculum for this session. So as you're learning this, and it does take time, and it takes the experience, and it takes putting it all together on your boat when you're using your chart plotter, if you have radar, and just being in the moment with it, being in present moment with these things and how you deal with it. And so my partner in crime this evening, and every time I get to do this, is my dear friend and colleague, Alex Avalos, who is a senior meteorologist with Weather Routing Incorporated. And so I am going to hand over controls to Alex, and I am going to go ahead and stop talking for right now and let Alex take it.
All right, here we go. And thank you again, Deb. I will just need to have participant screen sharing disabled or re-enabled, I should say. And then we can rock and roll. All right, here we go. Perfect. All right, so onward with part two. And Deb, thank you again for your kind words, and looking forward to the second half of the discussion. For those of who are joining us from the first part of the webinar tonight, welcome back, and we're glad to have you here. So now that we've focused on the first half of this presentation, which was more of a nuts and bolts discussion on weather, we're going to move on to the second half of our discussion for the evening. So this discussion is going to take a little bit of a different approach than the last one. Obviously, on the last one, we talked about the hows with respect to how some of the things, some weather works, and also how surface analyses can be interpreted. But this discussion is going to focus more on the perspective of the sailor and for things to be aware of and to prepare for, basically with the goal of ensuring that you have the most favorable window to be on the water. And there are a number of topics we are going to focus on for this presentation, including cloud progression. Clouds do tell a pretty unique story as to how the weather patterns are evolving, whether there's anything you need to be concerned about, or if not. We're going to talk about applications for using those surface analyses and how you can use surface analyses to determine what kind of clouds you might see in certain scenarios. We're going to go over, the planning of your trip to make sure that, you are, things to consider before hitting the water to make sure that you are going to have the safest and most comfortable transit, and things to take into consideration while on board. We're also going to go over common trouble areas to be aware of. They say every day is an adventure, but at the same time, having a deep knowledge of some of these trouble areas will save you a lot of time, and by being prepared for them and any rough weather that they throw your way. Tie it into the next point, preparing for adverse weather. We'll also go over, some considerations for local sailing, such as from nearby ports versus offshore sailing, which may be a longer passage, more likely to subject you to rougher weather conditions. I will talk a little bit more in detail about our services and how we can help you get safely and comfortably from point A to point B. We'll also go over some of the other available weather resources that are out there for sailors alike. Then I'll also conclude the discussion with a little bit more about our supplemental service called seaweather.net. So without further ado, let's carry on to part two. I tell you, I could be a poet and I wouldn't even know it. All right, so cloud progression. So basically, as I said before in the lead up to this, the clouds can offer a very, offer several clues as to, what the weather might do, in the near future. So while they can be benign and unremarkable in any given moment, they certainly can give us clues as to further developments with the weather forecast over the hours and the days ahead, as they usually do change in advance of approaching fronts and systems. And we'll go over those in a bit more detail. Um, you all know the saying, red sky in the morning, sailors take warning, but red sky at night, sailors delight. Little fun fact about that. Basically, what that's caused by is an abundance of water vapor in the atmosphere. And this same water vapor leads to cloud development, but it also helps to give the sky the reddish hue. And when weather moves from west to east, as it does in most cases, it can indicate that clouds and hence precipitation will also be moving in from the west, if the red sky is visible during the morning. But of course, the opposite tends to be true in the evening when you see the red sky in the east. Basically the weather is moving eastward and out of the affected region. So whenever you see red sky at night, sailors delight, that means that the weather is generally going to be improving in the nearer term. So taking a look at cumulus clouds, on their own, they're usually pretty unremarkable and fairly benign. They're basically puffy cotton ball-like clouds, the cotton ball structures. They don't really produce much in the way of weather, although they can when you have a bit more moisture to work with. Because they have limited moisture, they usually won't vertically grow significantly. But usually they are an indication that there is at least some instability in the atmosphere. They can be found in clusters, as you can see in this image, or sometimes they can appear as lone wolves in the sky. And, you could have blue sky as far as the eye can see, and then you have cumulus clouds occasionally dotting the sky. So you can find them in either of those scenarios. Usually, like I said, they won't result in rainfall or precipitation, but they can, they can certainly be a harbinger for things to come if the chips fall the way that they should to allow for this to happen. So when you do have greater degrees of instability and surface moisture, those are two key ingredients for further thunderstorm development. And thunderstorms result from cumulonimbus clouds. Cumulonimbus clouds can be very indicative of intense thunderstorms. And when you have intense thunderstorms, you can get damaging wind gusts. You can even get hail and frequent lightning, and you can even get water spouts. These can be very common ahead of cold front passages, and they can be found along a squall line, a complex line of thunderstorms. Basically, what happens is when you see this anvil of air, or this anvil develop, basically clouds develop when they rise. The parcels of air rise with time, and as they do that, they condense as warmer, moist air encounters cooler, drier air. You might remember that from the first discussion. And then once they hit the stable layer of the stratosphere, they can't rise any further. So basically, for parcels of air to rise and condense, the atmosphere has to be unstable. But once they hit that stratosphere, they're no longer encountering unstable air. And as a result, the only place that the condensed parcels of air can go is outward. So that gives these clouds this beautiful anvil shape, as you can see in this example. They can grow quite tall too. Between 10,000 feet and 52,000 feet are usually the norm. But certainly they can even approach 70,000 feet in the most extreme of circumstances. So out on the water, there's certainly, a concern and something to not be taken lightly. But the good news is you do have, given that, the open waters, whether it's out in the, western Atlantic, or whether it's on one of the Great Lakes, you do get that that wide view, and you can see these from a pretty far distance. So you at least know that there could be trouble brewing on the horizon. But these clouds can get quite significant, and the weather can turn very volatile, sometimes on a dime. And so being able to have an understanding of what these look like to the naked eye can help you plan in advance for any bailout options that may be necessary. So ahead of larger scale storms, cirrus clouds on their own too, they seem pretty harmless. You can even see them in fairer weather conditions. But these are high altitude ice clouds, and they can be found anywhere from 10,000 feet to 60,000 feet above the ground. So similar to cumulonimbus clouds, but the overall effect of both of those clouds couldn't be further apart. These clouds are thin layer clouds, and they contain higher concentrations of ice given their higher altitudes up to 60,000 feet. You can find these often with warm front passages. And basically, as moisture increases, these tend to become more dense. Usually one of the first signs that a weather system is within 24 hours of reaching an area in question is the presence of these cirrus clouds. Another type of cloud that you will find ahead of larger scale storms includes altocumulus clouds. These clouds usually are found at lower altitudes than cirrus clouds are, and sometimes considerably lower. They can be found between 6,500 feet and 20,000 feet above the surface. These are also made up of, these are made up of water droplets, but, depending on the temperature and the altitude, they can certainly turn into ice crystals as well. These clouds, while they do have a puffy texture to them, they're not as puffy as cumulus clouds. And these usually occur after warm front passages, unlike before them. Cirrus clouds tend to occur before those. And you'll usually see these developing within about 12 hours of the onset of a system, and before its associated rainfall or snowfall, depending on the type of precipitation that is going to result from it. And so at this point, we've now hit the pinnacle of the unsettled weather conditions, and you'll usually see nimbostratus when the weather really tends to turn for the worse with these larger scale systems. Basically, what happens is, nimbostratus clouds are lower in altitude than their predecessors are. Usually with these, you tend to see reduced visibilities, and that can result from a couple of things. That can result from heavy precipitation that may be ongoing, but it could also result from fog if the cloud bank is just too low to the ground. Now, visibility will tend to worsen as the storm progresses and reaches its peak, but that will begin to improve as the system moves out of the region and conditions by association also improve. And also visibility will improve if precipitation diminishes. Now that won't necessarily mean that the system has cleared out of the region per se, but if the precipitation has diminished, that's usually going to be a signal that there has been some improvement in the conditions. So now we're going to talk about, we're going to take a look at surface analyses, and we're going to talk about common cloud types that you might find with them. So we were talking about in the first discussion, the self-weather briefings. This next section is going to aim to help you understand, if you've done a weather briefing using surface analyses, what kind of cloud types you might find. Those cloud types can give you clues as to whether, there's nothing to be concerned about, or whether there's trouble brewing on the horizon that's going to require you to either A, find alternative solutions to bail into port, or if you have the green light, to make the passage for the duration of the way with zero concerns. So common cloud types that you'll find within areas of high pressure ridging. You can see in this example, there's a pretty vast area of high pressure, basically extending from southern New England down to the Carolinas, offshore of the Carolinas towards Bermuda, as well as into the Ohio River Valley, ahead of a tropical cyclone affecting Florida. You will tend to see in those cases cirrus and cumulus clouds. Yes, high pressure ridging is associated with benign weather. And as I said before, cumulus clouds tend to be benign too, but they can be indicative of some at least minimal instability. Um, Basically, you can either have clouds such as cirrus clouds and cumulus clouds or no clouds at all. And in a case where you wouldn't have any clouds at all, basically what's happening is high pressure regions are marked by sinking air motions. So when you have sinking air motions, that's very inhibitive for cloud development, and especially significant cloud development. Um, Another challenge that might result from high pressure ridging versus, ahead of fronts is that the direction of movement of these clouds can be variable. So you can't really determine as clearly which direction these clouds might be coming from as if you would, with cumulonimbus clouds out of a cold front, for instance. So that's something to keep in mind too. But generally with high pressure ridging, there's not, at least in the immediate term, anything to be significantly concerned about. So as we talked about in the first discussion of before, troughs and fronts do have their similarities in terms of the kinds of weather that you can see with them. The biggest difference, of course, being that the cold fronts tend to be more volatile, and weather associated with them tends to be more severe than it does with troughs. But troughs tend to serve as a wind boundary and instead of a wind boundary and a temperature boundary. You can still find cumulus and cumulonimbus clouds occurring ahead of trough passages, and you can still get thunderstorms with them. Although, like I said, the activity associated with them tends to be less severe than with their cold front counterparts. So that brings us to cold fronts. You'll recall from the first discussion a similar image of a cold front shifting off the East Coast. Cold front passages can be one of the more problematic scenarios for boaters. Of course, tropical cyclones is pretty far up there, but that not included. Cold front passages, like I said, lead to volatile weather patterns. Certainly things can change on a dime. And so certainly having a firm understanding of where the weather is, whether it's via the naked eye or if you do have a Doppler radar on board to understand where the weather is in relation to you, having those at your fingertips will be paramount. Usually with a cold front passage, there will be warning signs. Cumulonimbus clouds develop ahead of these front passages. And when you're out on the open water, like I had said before, you can see pretty far away. You can see for miles and miles. If you have an understanding of where you are with respect to where the cumulonimbus clouds are, usually those occur with the front passages. So fronts move from west to east. So if you have cumulonimbus clouds generally to your west, that's a telltale sign that you should at least be prepared to take action if needed to get off the water. Some exceptions might be the timing of the day. If you're making these passages, during the heat of the day or the late afternoon, and you see cumulonimbus clouds bubbling up to the west, you could pretty much assume that, you should at least be prepared for some thunderstorms, if not stronger to severe weather. Sometimes you have scenarios where these thunderstorms weaken when they hit the coast, but that's not always the case. If it's after dark, usually these thunderstorms weaken with the lack of daytime heating or the loss of that and the instability that goes with it. But certainly when you see these cumulonimbus clouds off to the west, it's good to have a firm understanding of where you are in relation to them to determine if you need to get off the water or if it's safe to stay on the water. So that's basically how cold fronts, you can find cumulonimbus clouds in association with cold fronts. But, you don't even need to have cold fronts for cumulonimbus clouds to develop. Deb had mentioned it earlier. For example, in Florida during the summertime, you get thunderstorms that develop on sea breeze boundaries, and that's caused by a differential in the land-based temperature and the sea surface temperature. And you basically can set your watch to them in Florida during the summer months because you get these sea breezes to develop, which result in a convergence zone, which gives way to the development of cumulonimbus clouds. So you don't necessarily have to, see a cumulonimbus cloud to observe a cold front passage. They can occur in areas wherever, there's prime daytime heating during the afternoon and evening hours. So with respect to warm fronts, altostratus and nimbostratus clouds can be more prevalent with warm front passages. Likewise, when you have warm front passages, the weather tends to be less volatile than with cold front passages. But, you can still get unsettled weather. And heavy weather, is certainly not ideal. Heavy rainfall is not ideal. Certainly it would not be a pleasant time to be out on deck, when that occurs. So while it's not as much of an immediate threat to safety as severe thunderstorms and squalls would be, or even water spouts, it's still something to keep in mind, because even then thunderstorms can still occur, even if they're not as severe. And with every thunderstorm, you have to be concerned about lightning. So that's something to keep in mind. So whenever you see a warm front passage on a surface map, chances are it will be unsettled, but it may not, depending on one's personal preference, be the dictating decision as to whether one gets off the water or not. So, of course, it all starts with planning your trip, as far as getting out to sea. Planning for various weather circumstances is paramount. Always good to know what the tolerances of your vessel are, but also as well as for you and your crew. Having that firm understanding is paramount, because that'll give you a firm idea as to what you're willing to tolerate, what you can tolerate, or what you would prefer not to tolerate. So knowing your vessel through and through to start is always a great fail-safe starting point, and a path of least regret before you hit the open waters. With sailing vessels, there is, an added layer of complexity versus a motor vessel, for example. And, there's a sensitivity to be warranted, because they do not travel as fast as motor vessels. We work not only with sailing vessels, but also with motor yachts too. And one of the things I can tell you is, when you do have heavy weather approaching, motor vessels do have the option to increase their speed. But because sailing vessels are limited by a more limited motoring range, and they might not have the fuel on board necessary to, speed up and get ahead of approaching weather features, there's an extra level of care that needs to be considered here. So knowing what your vessel's limitations are and what they're not, having backup plans to bail out on the coast if needed, are all important considerations to look into when you are getting ready to hit out on the water. So that's all lumped in with yours and your crew's tolerances, when you make these passages. And so if you're staying local, though, it's easier to keep in mind bailout options. But if you're proceeding further offshore, maybe on a longer passage, having an understanding of what the weather is going to do is also very important. All right, so further things to be concerned about or consider when you're out on the water. We discussed, making sure, or whether we discussed whether your vessel. We had a discussion about, is your vessel ready, and is the crew ready to be out on the open waters when rough weather hits? Well, unfortunately, Mother Nature doesn't always plan for us to be as prepared as possible. And the weather in some areas of the world just simply doesn't cooperate. And it's, for those who have been out on the water over the years, certainly there's an appreciation of where, these conditions are going to occur. So, a lot of these trouble areas occur right here in the United States, and they even occur in the Caribbean. And a lot of these areas tend to be affected not only by weather patterns, but complex topography can play an outsized role. For example, the Mediterranean, it doesn't always come down to, fronts or troughs. the local topography in the Mediterranean can play a significant role as well in affecting the weather patterns. So we'll go over just a few of the areas around the United States and the Caribbean in particular, that are certainly subject to rough weather conditions, given any time of year. Hispaniola is a common one that includes places like, the northern stretch of Hispaniola beyond Great Anagua over towards Mona Pass. There's also Cabo Beata along southern Hispaniola, which is also a very troublesome region. And I can tell you, having done many forecasts for vessels hoping to go down that way, model data doesn't always do a very good job with forecasting the winds along southern Hispaniola in particular. And a lot of that also becomes the result of localized funneling due to terrain in those areas. So that just further underscores the benefits of adding the human element to the forecasting to help give you the most comfortable transit possible. So there's also Colombia, which is another troublesome area, and I know Deb and I have worked in that area with forecasting before. It's certainly not a picnic at certain times of the year. The tongue of the ocean and the banks and the Exumas is another troublesome area. We'll go over that in more detail as well. Cape Hatteras, as well as Cape Mendocino and Point Conception through the Santa Barbara Channel are just a few. Now, of course, here's another thing too, depending on how you look at it, certainly you can have the winds that will, give you favorable sailing angles for sailing, but if you hit them the wrong way, it can be very far from ideal, such as if the winds are on the nose, or if you're bashing into the conditions.
Alex, may I?
Yes, go for it.
So, yeah, so Alex pointed out several capes that anyone who's traveling around the United States coastlines have to deal with. And they do have very specific weather systems. So it's one of the great things about sailing and this boating community that we're with is there is also good people to go to for local knowledge. So for instance, when you're rounding Cape Hatteras, having that local knowledge when you've gotten your WRI report, you have your weather, but talking to the guy who's the fisherman or the Boat US, Towboat US guy who's out there pulling in the guy who's had a problem is always awesome. So you have lots of resources that are available to you when you are going around some of these very interesting places that do have weather systems. And so you want to ask lots of questions.
Absolutely. Thank you, Deb. Thank you for that. And yeah, it's certainly, if you're transiting in these areas too, if you're sailing in these areas, flexibility is another thing that I would strongly recommend too for anyone who's going to be out on the water. What I mean by that is, you find stretches of time where the pattern is just awful. And we're actually heading into that time of year now. The Christmas trades are settling into the Caribbean. We're finding that vessels right now working their way down from Florida to the Caribbean are either going to be seeing higher winds that are going to be on the nose, or they're finding themselves delaying, waiting for a better window, which, poses challenges because they can be quite lengthy this time of year. For vessels, they're heading right into the conditions, versus leaving the Caribbean and heading to Florida where it's all behind them. So that's, the flexibility component is something I would certainly add, to anyone who's looking to make a transit in these areas we're going to discuss. So without further ado, beyond Hispaniola, the trouble areas don't end there. Northwestern Colombia is another one. This time of year, when you get a thermal trough that develops off of Northwestern Colombia, and then stronger ridging further to the north, from the subtropical ridge settling further to the south in the winter months, the interaction of those two features really results in stronger northeasterly winds. But this time of year, because the cold front tracks are also further south, when a front shifts across Florida, you tend to get that ridge to break down. And when you get that ridge to break down, the interaction between the ridge and the trough also does the same. And so these windows can open up across northwestern Colombia and become more favorable. And I should add that scenario applies to Hispaniola as well as the Bahamas, which we're going to talk about here in short order. But persistent funneling of northeasterly winds along the coast causes shorter period seas to stack along the coast, which is also a process that's known as shoaling. But when you get a weakened interaction between the ridge and the trough, usually that allows the trough to weaken as well. And that could be the time frame in which you would expect to find a window to make a passage here. Same thing across northern Hispaniola and Cabo Beata. And that scenario applies to the Bahamas. So in the Bahamas, basically the common concerns you find here, oftentimes, like I'll use the trade regime that we're in as an example. You get a larger sea state that propagates into the Northeast Providence Channel. You can, in other instances, get larger but longer period swell propagating through the Northeast Providence Channel into the tongue of the ocean when you have a larger gale out in the Western Atlantic that's propagating that swell in that direction. So, as you work your way south through the tongue of the ocean, the sea state can be a bit larger there, but not as large as further north when you get those persistent trades persisting. And the reason why they're smaller further south into the tongue of the ocean is because you have the protection of the Great Bahama Bank. And when you have that lee protection, the fetch is smaller and thus the sea state is also reduced, most commonly in this area. But you can get wraparound swell that works its way in, but the sea state would tend to be largest, basically from the Northeast Providence Channel to Nassau and to south of Chubb and the Berry Islands, if you were, to get a strong trade regime or a large gale passing close by. Now, the Exuma Banks, on the other hand, can be a great place to sail in the winter if you're looking for the wind, and the sea state's not as much of a concern over the banks. So certainly the Bahamas could be more favorable in those areas than other regions because you don't have that same sea state that's building. But it can become beneficial from the perspective of sailing with good wind angles. Now, working our way back to the States, Cape Hatteras, this is a very notorious area for rough weather. I can tell you, having done forecasts for so many vessels working their way up and down the coast, the fact that the Gulf Stream is in close proximity to Hatteras doesn't really do anyone any favors. When you get a cold front approaching from the west, Hatteras is one of those areas with the unique scenario where you get funneling southwesterly winds and funneling northeasterly winds, depending on what side of the front you're on. And as we head, when we go into the fall, you tend to get these fronts shifting further south. So the southwesterly winds tend to be more of a problem for vessels working their way south. But another conundrum is you tend to get stronger ridges to build in the wake of these fronts. So you get the northeasterly wind component to build in as well. So you either A, hit the southwesterlies working your way south and hit the head conditions, or you get the northeasterlies in close proximity to the Gulf Stream, which, just like across the Florida Straits, is just as problematic off of Cape Hatteras. So the moral of the story is when you get those northeasterly winds off of Hatteras, there's no good window really to get around. When the wind's out of the southwest, it's always good, during the summer months, if you're working your way south and you're out on the open water, take a look to the west. I've been to the Outer Banks many a times during the summer months, and it's very common during the summer months you get those afternoon thunderstorms bubbling up. So it's always good to keep an eye to the sky to the west when you do have a scenario where it's a hot summer day and you have the southwesterly winds in place. If you see those cumulonimbus clouds, it's worth considering pulling in. And if you're in a scenario where the front passes through, and you are carrying on, be mindful, of course, of those funneling northeasterly winds, which will be in place along Hatteras and the southern Outer Banks. Now, turning it over to the West Coast, California is a hot spot to a couple of trouble areas. The most common ones include Cape Mendocino and Point Conception. Cape Mendocino in particular is one of the more challenging of the two, and that's owing to the presence of more persistent north to northwest winds. You get those at Point Conception as well, and I will go into that a little bit here shortly. But the trough axis tends to be more stationed across northwestern California and closer to Cape Mendocino. It takes a lot more for the trough to break down. Usually heading into the spring months, we begin to see signs of that trough developing, but because the cold front trajectory is still a bit further south, that can break down the trough interactions. As we head into the summer months, the temperature gradients between northwestern California and off the coast tend to be larger, so the thermal trough is stronger. But the problem is that cold front track tends to shift further north too. So there's really not anything to break it down. And vessels that are looking to head north from San Francisco during the summer are going to find themselves delayed for long periods of time, sometimes for a week, if not longer. That's another scenario where flexibility will really, really come in handy, because I've seen scenarios where vessels are stuck for weeks at a time in San Francisco, and that can be dependent on what the crew and captain are comfortable taking the vessel out in. Certainly more sensitive scenarios would require greater flexibility. And then, as I mentioned, Point Conception is another troublesome area. The trough tends to be set up to the northwest. So any surges in northwesterly winds here at Point Conception tend to not be as long-lived. But one of the challenges of Point Conception is that you will get those seas wrapping around the Cape and into the Santa Barbara Channel. So the trouble doesn't always end right at Point Conception. Certainly you will have to have the flexibility to get around Point Conception as well. And, certainly there's fortunately more bailout options in Southern California. When you work your way north towards Cape Mendocino, it's really Monterey and San Francisco. But in Southern California, depending on which direction you're going, you have places like Morro Bay, San Luis Obispo, Santa Barbara, the Catalina Islands, and even Los Angeles, along with Oxnard, for example. So, more options to stop further south and greater opportunities to minimize your delays just based on the overall nature of the thermal trough across the state of California. So it's always good to be prepared for the most severe weather. We've talked about this in bits in this discussion tonight. Many hazards are out there on the water for boaters. In an ideal world, the weather would be benign and cooperate, and there would be wind available to sail. But unfortunately, that is not always the case. Sailors need to be keenly aware of strong winds, that might result from a high, for example, or larger seas, which may threaten comfort. Strong thunderstorms are a big one, including frequent lightning, damaging winds, and heavy downpours, and water spouts. So we'll go, basic, excuse me. You'll want to know when the weather is going to strike. And, of course, there may be limited access to radar. Of course, with Starlink, as Deb had touched on earlier, there may be more ready access to take radar out onto your vessel to monitor the weather more closely and understand what the latest trends and developments are. But if that's not available to you, knowing cloud structures and how those evolve can give you ample clues as to what the next 12 to 24 hours may entail. One exception to that on the time frame scale are cumulonimbus clouds, which tend to develop pretty quickly and can become very violently pretty quickly. So those are things to keep in mind. And touching briefly on wind directions, if the wind's out of the southwest, for example, and you're looking to your west and you see cumulonimbus clouds developing, it's a good sign that there's a cold front approaching and the weather might turn on a dime pretty quick within the next few hours. So,
One more time on that, please. So if you're looking to the west.
yep. If you look into the west, go ahead.
Yeah, so I want you to repeat it because it's
Yeah, no,
really
absolutely.
important.
Absolutely. No, I'm happy to do that. So let's say, you're in like offshore of the Outer Banks of North Carolina, or if you're on Lake Erie or Lake Superior, and you see cumulonimbus clouds bubbling up to your west, and then the winds are becoming gusty and out of the south to southwest. There's a good chance that a cold front might be on your doorstep. And things can change very quickly and on a dime when you have a cold front approaching, when you have cumulonimbus clouds developing. So not only can the conditions change on a dime, but all weather hazards that we've discussed with frequent lightning, damaging winds, water spouts, they can all come into play really quickly. So one of the things too that we're going to talk about is water spouts here in the next slide. So one of the biggest issues with water spouts is that they're very erratic. You can't really 100% or predict with 100% confidence exactly the track a water spout is going to take. And usually they wobble, but sometimes they can turn in other directions that, we really don't want them to when you're out on the water. So, water spouts, it's definitely the biggest thing that you want to keep an eye out when you have thunderstorms in the forecast because of the significant risk that they pose. Lightning is, of course, another concern while out on the water. You can use the 5-second rule with that. So for every 5 seconds that between lightning and a clap of thunder, is 1 mile. So, the closer the lightning strike and the thunder are, the closer the thunderstorm is to you. Darker horizons tend to be common with approaching thunderstorms. So, being out on the open water, you can see that for miles. You can take more evasive action if needed. Being out on the open water because you can kind of get a better feel for your surroundings and where, water spouts might be moving or where thunderstorms might be approaching from. So that can really help you to, mitigate any risk and determine if you need to pull into port or if it's basically safe to continue as you intend. So now we're going to kind of turn over towards the tools that you can use to help keep you safe on the water. So we'll start with some of the more common weather resources such as NOAA, as well as mobile and desktop apps. The bottom line is there's a wealth of information available to you online and to the rest of the general public. And that includes resources like NOAA. There are various resources such as Predict Wind, Buoy Weather, Windy, Time Zero, etc., which are available to the average user. The biggest downside with respect to these, with the exception to NOAA, is the lack of a human element to the computer apps. So bottom line is that, model data, it churns the data, but it's not always accurate because model data, I've found one of the biggest pitfalls is it doesn't take into consideration local terrain effects. So for example, off of Northern Hispaniola or Cabo Beata, model data tends to significantly underdo wind forecasts in those areas. And that's just because the models don't really have a good handle on what, the pattern or what the terrain is doing to enhance the winds. So where the human element comes into play and is of particular advantage is, folks like myself, for instance, we've recognized patterns over time. And when we can use that pattern recognition to determine, okay, so the model is likely underdoing the winds here, or, this area is going to be a bit more troublesome than the models are showing. So, having that human element taken into consideration will help to give you a leg up on understanding what you're up against if you're going to be out on the water than what might be the case if you're using a mobile app on your cell phone, for example. So these models can be subject to high degrees of error, but having that human element and someone to work with can really help to minimize that error and at least make you better prepared for what's to come. So a little bit more about offshore sailing versus local sailing. And I've mentioned this a few times already in this discussion. Having the flexibility for your trips is paramount. And I say that especially for offshore sailing, primarily owing to the fact that offshore sailing involves more miles. It also involves having fewer bailout options immediately available and potentially exposes you to more adverse weather conditions. So understanding, having the flexibility before you get underway and having a firm understanding of the forecast will be best. So the weather may not cooperate for your offshore passage. Knowing that beforehand will work to your benefit. Things you can do, to prepare for offshore sailing versus local sailing is having a good fuel supply to motor if needed. Because sometimes, there's lighter airs in place where you're going and you're going to need to motor. The pattern just won't be conducive for sailing. Now, there are sources available to you, such as weather routers, like what we do here at Weather Routing Incorporated. You can work directly with our degreed meteorologists. And like I said, we have that knowledge of local geography, which can affect, weather patterns in given locations. And we do forecasting worldwide. So, we've done forecasting for the Mediterranean, for the Caribbean, for instance, all around the world, wherever you're sailing, we got you covered. So we work with you to make sure that, you're getting the best bang for your buck, if you will, with making sure that you have a firm understanding of the forecast. Leave it to us to help, determine what the local geography is doing with respect in comparison to model data to make sure that you're getting the most accurate forecast possible and that you're not being caught off guard.
Hey,
So we made,
Alex,
yes,
sorry. Can we go back one slide, please?
absolutely.
Um, Guys, one of the other places where you're going to find, we talk about when we're going offshore that when we get into heavier conditions, there are many times that it's not just the lighter conditions that we need to have fuel. We need to have our engine on to be able to address the conditions that we're dealing with.
Mhm.
Um, uh, because just being under sail isn't going to be sufficient. And
Right.
so, and there may be times where the weather is such that we have to really reef in. Um, and so we're using more fuel. And I think that probably what was shocking to me once we left the Bahamas and the United States, got into the Caribbean was how many times we were required um, because of the conditions that we did have to use additional fuel. So um, as Alex pointing out to you, it's very conditional based on whether you're doing local sailing or offshore sailing. And having these resources and this partnership is really critical with the services that you have available, like WRI. But also, you're going to find out what you're comfortable with, and this notion of making sure that you're not bound to a schedule. And
Right.
that schedule, we were, excuse me, I have to say, we were stuck in Turks and Caicos for 6 weeks because we could not get a weather window to get to the Dominican Republic. And oh my gosh, did I really say I got stuck there for 6 weeks? It was marvelous. However, there's only so much island, and there's only so many days that you can go diving and that you can go and do and do and do. However, to wait for that proper window is what we were required to do. And with the partnership with WRI that we have, we were able to make that, and we had a window. We had that small, tiny window. And we just, because of the nature of our boat, we had to be aware of that. So I just wanted to put that in there instead of coming back to it. Thanks, Alex.
Yeah, of course. And I always appreciate your insight and any further elaboration. And thank you again.
Okay.
Yeah, so with respect to WRI, we provide recommendations to a clients based upon the weather thresholds they provide us. So basically, safety and comfort are our top two priorities. So what I mean by weather thresholds. So let's say you wish to not be in winds in excess of 30 knots. So if you tell us we're looking to leave from Fort Lauderdale to head to Nassau, and I don't want to be in winds of 30 knots, if the forecast for that departure calls for winds in excess of 30 knots, we're not going to validate it. And instead, what we'll do is we'll let you know of an alternative departure date that's going to both satisfy your thresholds and also be the safest and most comfortable passage for you. So we consider all options on the board. If it turns out that your departure window is not valid, because safety and comfort are our top priorities, we want to make sure you're on that best departure window. We also will recommend the most favorable route to you as well, to make sure that you're getting the most favorable angles for sailing, that you're on the route that has the best seas possible. If you can make progress from point A to somewhere else before the weather turns bad, we'll work with you on that as well, and then recommend the next onward departure to get to your final destination. So basically, you can see here in this image, this is what an example of our forecast looks like. It's in a tabular format for every 3 hours for the first 3 days, and then it's a 6-hourly forecast beyond that 3-day mark. But we strive to make sure that our clients are enjoying their passages, not necessarily just that it's the safest trip from point A to point B, because each crew is different, and the tolerances are more or less sensitive depending on the situation. So we base it off of your specific needs and how you want to enjoy the trip, if that makes sense. So, we're available 24 hours a day, 7 days a week. We have close to 70 meteorologists on staff, and we do forecasting worldwide. So there's a wide array of individuals you would work with here. So regardless, of how you obtain your weather forecast information, it is definitely important to trust the resource of your choice. For a provider who is deeply rooted in the science of meteorologist, that will offer you the peace of mind when you need to make weather-related decisions, which improve the safety and comfort on board. Accessibility is also another important benchmark. You may be on the water and you need to make urgent decisions related to weather that could mean the difference between comfort or potential damage to the vessel, or upset seasick crew. Is your provider accessible at all hours of the day and night, that if you called them, you could get a quick answer, as to what you would, be up against. And also, does the provider have a reputable track record? Now, if you may be looking at local news stations, on-air talent, it's important to scrutinize that as well, because the same patterns that drive the weather in Phoenix, Arizona, for example, are going to be different than the weather patterns that affect, Raleigh, North Carolina. So having meteorologists who understand their local region altogether is very important. And that's going to be the best case scenario to help you get the most accurate forecast for those regions. So lastly, I briefly mentioned this at the beginning of the second half of the discussion. We do offer that supplemental program called seaweather.net. This is a very beneficial service for independent planning purposes. We do offer a voyage planner service on it, which allows you to plot up routes against various weather parameters such as wind, seas, sea surface temperatures, sea surface pressure. If you did wish to try out our services, you can feel free to call us or email us at any time at the number you see on this page, as well as the email you see on this page, and let us know that you learned of us from Deb Marler's webinar. You would be entitled to a complimentary forecast and a sea weather trial. So with that, I will turn it back over to Deb.
Great. Okay, guys. So questions. Who's got questions? I see some leaning in. Do I have some guys coming on to give me a question?
I had a question about
Yep, Tom.
those undulating
Perfect.
clouds that were in that
Yep.
one of
Yes,
those
you did.
photos. That was very spectacular. I've never seen clouds like that. What kind of clouds were they, and what makes them form?
Yeah, so I mean, those are altostratus clouds. You could kind of another name that they can have is gravity waves because they look like waves.
Mhm.
So basically, those are associated with larger scale weather features like lows. Basically, they develop in a lot of the same ways that other clouds develop. But what happens is that instability is shallower, and the moisture content is not as significant, at the surface as it would be for like a cumulonimbus cloud. Um, you know, I'm not sure the exact mechanic behind the gravity wave feature of it, but basically the same mechanisms that would result in the development of clouds in a general region. So surface moisture, and a nearby system for some localized instability would be the primary drivers of that cloud development.
It looks like two layers of air masses moving by each other and causing instabilities at the interface.
Yeah, it kind of does. And one of the things that's really cool, if you look at it on satellite imagery, it looks just like waves. It's a pretty spectacular cloud to look at. I have to agree, it is probably one of the more spectacular cloud features to view.
Thanks.
You're welcome.
You bet. Right. Carl, you are asking for WRI. Alex, can you put your contact information in chat? And just know,
Yes.
everyone, that when I send my follow-up letter to you, and with replays, I will have Alex's contact information and a reminder. This is how you get a hold of Alex, so that for your complimentary forecast. So that will come to you again. So, if you missed it tonight, you'll get it. And one of the things that I wanted to address in some of the cruising courses that we're teaching and that I'm teaching, the importance of really understanding the topography, understanding, we touched on early on the Beaufort chart, and that Beaufort chart should be embedded in you. You should be able to look out at the ocean, and you know exactly what the weather is. And one of the things that we get complacent when we're sailing our coastlines because we don't have this, especially localized, we don't have these dynamics that occur that we see in the Caribbean. So, for instance, when we're sailing in the Caribbean and we are by an island, coming up to an island like the Dominican Republic, we've got some water that is the deepest of anywhere in the world on either side of the Mona Passage. But we also have an island that's very, very large and higher, with four mountain peaks that are over 10,000 feet above sea level. So all of a sudden, there are things that are going to happen that you've never had to deal with before. And this is part of what we teach in some of these cruising courses, so that you have a better idea of what you can do as you are going into the Caribbean, so that you can really manage this better. The day-to-day weather, we've got to have it. Every time that we go on a passage, we've got the team at WRI. That's number one. But we're also looking at our localized, the localized information, as I mentioned to you before. We're also looking at the topography differences and the things that we have to deal with that, for instance, along that shoreline between north of Puerto Rico and the Dominican did not get traveled for 450 years. And there was a reason for that. And the reason was that it's treacherous. And so when Alex is talking about how are we impacted by the currents and the trade winds, it happens to us all of the time when we're out there traveling in our passages as we're moving south. And so you're having to deal with this, and you're having to deal with storms because you're going you may be going for a couple of days, and you may be doing overnights, and you're going to be able to use your nighttime sailing, and that's another whole nother conversation that we haven't even had. So there's a lot of information that we have in other courses, and there's certainly more, as you talk one-on-one with the meteorologist at WRI, that ask your questions, and certainly don't hesitate to send questions over to myself. And my husband and I both will answer. He had a man chat for us tonight. So he was answering some of your questions, and we're here to help. We want to make this easy. And we also, I will tell you, I would love for you to learn what nobody told me. And that's why I built the courses that I built in the way that I have. So again, Alex, I want to thank you. What a great partner you are. Does anyone have any other questions?
I saw that Claire had asked a question about methods of communications. I'm happy to jump in on that one.
Okay.
Thank you, Claire, for the question. So yeah, I mean, Starlink is definitely is an increasingly reliable service. And I've observed in working with clients that more and more are investing in that. If that was not the route you wished to go, it's very common that we've observed vessels using Garmin InReach, for example, as well as Iridium Go. Those are common text method options that also work and allow you to keep in communication with those on shore, and if you were working with a weather router, with them as well.
Yeah, Claire, the thing that I would say, especially for those of us who still work, and having to be in communication a lot, even when we're at sea, Starlink is a game changer. But see, Starlink is the connectivity. That provides our internet. And so we can get email, we can get the information, just like we normally would as if we were sitting in our home office or we were sitting in a corporate office. So that is available to us. And there are, Starlink was the first to market. So are there other companies that are coming online that are going to be offering the same thing? Yes, there are. And so there have been tons of changes and updates and programs that are available to you. But for normal communication and connectivity, I can tell you that for 90% of our trip into the Caribbean, we were doing cell phones and we were getting a SIM card in every country. And so we had to be line of sight to a mobile tower. And and that November, we got Starlink, and it just changed the world. So I can't stress it enough as far as, is it reliable? You bet it is. Do they have some problems from time to time? But most every cruiser who's out there is going to tell you that changing and having Starlink has been a game changer for them. These other tools, we have them as redundancy and a resource, so that if for some reason there is an outage, we have an outage, or we have to turn it off and we don't want to use that power, that is the one drawback, is that it uses a significant amount of power. And so for us, having our, in the past, it was InReach, now we have Zolia. So whatever tool works for you, find it and ask other people, what do they have? What do they like about it? What don't they like about it? So from my side, I'm going to be doing a comfortable cruising course. The one thing I also wanted to address, I would lay money that if you guys were giving Alex, doing your customization for your boat, and you were sending it in and you saying, here's our tolerances, please be sure that if you're traveling with your wife or your partner who may not be as rugged as you are, that you take into consideration what is her comfort level, or the people that you're sailing with, because that will also help. I will also say that after X number of years, you and I made some decisions and we updated our profile with WRI, and we said, we don't want to do that anymore. We don't want to do that kind of sailing anymore. And we want it to be a little bit more laid back. So again, this is personal preferences, but you have flexibility, you have options. And so we can certainly talk about that. Again, any questions?
I have a quick question for Alex.
Yeah, Diane.
Um, because it's in our bucket list to do an Atlantic crossing, does WRI have historical data on the weather patterns of the Atlantic Ocean, like for the last 3 years, so I can start looking at it?
Oh, absolutely. And what time of year were you looking to go?
Well, if we do not go with the ARC rally next year, we would do it on our own, taking the northern route. So I'm just trying to see what options we should take.
Yeah, yeah. Oh, absolutely. We do have access to that. And yeah, I mean, basically the big thing in the Atlantic is that we have to watch, especially as we go into the summer months, is the tropics. The Cape Verde season doesn't really heat up until August, September. And because of that, that's when we see the incidence of recurving tropical cyclones also increases. So certainly, if you did not go with the ARC, the later you can wait, the better. And even then, even if recurving tropical cyclones weren't an issue on that more northern route, you certainly would find yourself in the gale and front tracks. So it would definitely be very active at that point in time too.
Okay, so I'll be in touch with you then.
Perfect. Wonderful. Thank you for the question, Diana.
Great question, Diana. Anyone else? Well, then I'm going to draw it to a close. You guys have been troopers tonight. Thank you so much for your support and being here. My thanks to my partner in crime here tonight, Alex. Thank you again. Well done. And, again, I want to do a shout out to Aquamaps for all of those new people who have joined us tonight that came from that resource from me. And I look forward to seeing you at Comfortable Cruising on Friday night, January 17th. And have a very wonderful holiday season and stay safe out there, you guys.